Hi everyone, nice to see you all again. So it's a pleasure to welcome you all to our mostly live stream, xbytes as usual. So this is live stream from June, and this is our last live stream of this quarter, and that will be the last one, because we all will be taking a break until September. Um, it will be our summer season, our silly season, we usually say here. So, and to close things up, and to close things before this break, we have David Alecrim with us. Let me just put you. Yeah, welcome, David. So, David is a software engineer here at xgeeks. He's one of our staff engineers here, and it's very nice to have one of us to close these sessions of this quarter of live streams until September. So, thank you again, Alecrim, for accepting the invitation and this challenge. It's great to have you here. And David will be delivering a talk about strategic engineering, empowering teams for excellence. So I will not take longer because I know that the viewers are here to see you, and you will be more than able to speak about you than me. So yeah, the stage is yours, David, and a nice talk.
Thank you, Fabio. Can you just confirm that you're seeing the correct screen?
Sorry. Yeah.
Sorry?
This.
Okay.
Yeah.
All right. Hello, everyone, and thank you for attending this presentation. As Fabio mentioned, I'm here to talk about strategic engineering and how to empower teams for excellence. And what this entails is basically a collection of techniques, strategies, processes that I've observed in high-performing teams and that I've also put into practice, and how that can help your teams to be more productive. First, a bit about myself. So I'm David Alecrim, a staff software engineer here at xgeeks. You have here some personal information from me, my personal website, GitHub, LinkedIn. Feel free to connect. I'm always available to message anyone. And a bit about my background too. So I worked and have had the privilege of working with a lot of global brands and products. Some you may know, like DHL, Mercedes, Daimler. And I've also had the luck to be able to contribute to some really cool open source projects and also to create some open source creations of my own that have had quite a bit of reach. And I'm really glad about that. And over the years, I managed to collect a bunch of strategies and, like I mentioned, processes that really make teams stand out. And that's what I want to talk about today. First, we'll talk a bit about soft skill related topics, which are really important. Engineering is not all about code. Then we'll dive deep into technical related topics, and in the end, we'll save some time for a Q&A. So what about managing topics? What can make your team excel in this part? First, team documentations. And this may sound, well, petty or small, but this can come really important. And I'm talking about big corporates, big enterprises, but this can also apply to small startups. But this especially shines in big enterprises. So to have a team documentation where the mission is fully described, the composition of the team, who are the members, what roles do they have, how long have they been there, to understand what context does each one have, the ceremonies that the team has, and links to everything that is useful. Use software, licenses, internal tools, monitoring, reporting, alerting, everything that can be handy to an engineer should be in this team documentation. This is especially helpful, like I mentioned, for big enterprises, because it helps new engineers coming to the team to have one place where they can check everything they need to check regarding the team and how that team integrates into the product, which is, at the end of the day, what you want to contribute to the product. So this is the first technique that I want to talk about. Then meeting etiquette, which is many times overlooked, and it's a shame. But meetings should have agendas. Meetings should have agendas. You should go into a meeting fully prepared to talk about what's going to be talked about there, if possible. Everyone attending the meeting should be prepared also to attend the meeting. It should have a moderator, again, if possible, because meetings tend to deviate from the original topics, and that's kind of a waste of time for everyone there. And it should have outcomes. If you're going to spend time meeting about a topic, then this should have outcomes. It should have something that's assigned to someone so that further investigation needs to be done or someone needs to act on an outcome. So this should happen more often than not. Another strategy that I want to mention is Power of X, most commonly known as Power of 3. These are sessions that happen, again, in an agile methodology. So everything that's an agile process can have benefits from this. These are sessions to extract information regarding the topic, to refine features, to refine epics. It involves normally engineering, product design, but it can involve more people. That's why I call it Power of X and not Power of 3. It needs a moderator like in any other meeting, in my opinion, and it provides guidance to engineering in order to drill down tasks. So this is the main benefit that it provides. If all these people are present in the Power of X sessions, then bigger chunks of epics can be broken down, and senior engineers can more easily break this into smaller tasks so that any engineer regarding of seniority can work on them in the product, which is really helpful. And another characteristic of these sessions is that they happen recurrently. So they keep happening from time to time at the scheduled interval, so that you can have always a populated backlog of tasks for your engineering team. Another topic that I wanted to mention is acceptance criteria. So this adds expectations for engineering, product, and stakeholders for a ticket that is being worked on by engineering. You have an example here on the bottom regarding an authentication ticket. And what can everyone expect from this authentication ticket? Well, exactly what's written here. If these acceptance criteria are not met, then the ticket is not done, or it shouldn't be done. This helps a lot when you have QA engineers in a team or when you have a dedicated QA team, because they only need to check the acceptance criteria. They can check more, of course, but at the end of the day, they only need to check the acceptance criteria and test for that, either with end-to-end tests or integration tests. It depends on the teams and the products. But this is all they need to do to assess if the task is correctly implemented by the engineering part. It adds guidance for impactful test writing. And I'm talking here more about the engineering part and the engineering tests. It can help a lot writing integration tests for the engineering part, and that's really, really helpful.
Sorry, Alecrim, I was wondering during this particular slide about the criteria. If you can explain me, and I think that can be also a doubt and a question that our viewers are having. In what ways did defining the acceptance of criteria help you to write tests for the ticket, for example, or can you give me some examples?
Yeah, of course. So as I mentioned, they help guide the process of writing tests. And in my particular example, I worked in a team where every acceptance criteria was kind of a step or kind of an integration test that we needed to implement. And the way that we did that was with Cucumber definition, which was Groovy. And actually, we wrote the tests in English, everything in English, like Groovy. And then we had functions that implemented each of these acceptance criteria, and they were named after them. And then these functions that were really explicit about what they wanted to test, then they had the implementation of the tests itself, like the specifics, if you're using Jest or if you're using whatever. That can be quite syntax clear, but at least the function names following the steps that you need to achieve for each acceptance criteria, that's the kind of guidance that I'm talking about here.
Okay, thank you, David. Sorry, and go ahead. Sorry.
Thank you. So FRCs, ADRs, and DLs, or request for comments, architecture decision records, and decision logs, these are basically all documents to record architecture and feature decisions regarding a product, and these are really important. It's quite often that a team makes decisions. They have a context at the time, they have limitations at the time, and they do the best decision possible, taking into account that context, taking into account those limitations, and they choose a solution that properly fits those criteria. And this should all be recorded, because a few months later, a head of product or the CEO comes knocking at the door, and it's like, this is not exactly what I wanted. Why isn't this like I said? Or why isn't this following the product as we envisioned at the start? And these documents serve as a repository of knowledge regarding what happened, why it happened, and the limitations at the time that drove to such a decision. So this is really important for stakeholders internally. This is really important for the engineering team, because it's a place where we can always search why something technical happened. And it's something that can keep improving. So if we have an architecture decision record regarding the application architecture, but it no longer fits the needs because the organization has grown to a larger number of people, then let's work on a new ADR, work on the current architecture, work on top of this, and make it evolve and create a new ADR for people to review. ADRs, FRCs, decision logs, they should all have acceptance, people that make the acceptance of it. And they can be engineers, heads of whatever, as long as they review the document and have anything of value to add to that document. So yeah, this is a great thing also when you have quite a bit of rotation in teams, and this happens a lot in big enterprises too. When engineers keep rotating and keep leaving the company and new engineers keep coming in, it's a way to centralize decisions in one place versus having knowledge in the engineers, in the heads of the engineers, that then leave and may or may not leave everything documented as they should. So this is really important and something that I always try to do in any product that I work on. Then the last for the soft topics, the soft skill topics that I want to mention are sequence diagrams. Before working on any big feature or any feature in general, actually, I like to write sequence diagrams of what they will look like. You have an example down here, which is really, really simple, just to serve as an example of how adding a customer, a vehicle, and assign that vehicle to a driver may look like with an API, with a third-party integration. And this really helps to enable the technical thought before actually doing any code. So how do these pieces fit? And how will they communicate? And will the communication be backwards and forward, or will only be one way? So this enables to start thinking on the technical level without working on the code, which may help because it's a more high level and it's easier to have a grasp of every piece. It enables problem detection early on, because when you start thinking in these high level integrations, you start thinking, oh, but I want to create a vehicle here, but the third-party service doesn't provide an API for this. So how can I integrate this? So it's a problem. How can I solve it? And you reach this problem before actually doing any code, which may help also in the agile process, because a ticket may be plugged sooner or not. It may help quite a lot on the process of agile methodologies. It also enables the engineering team to clearly communicate at high level, between engineering itself, which is already really helpful, but also with product owners. They can read a diagram like this and they can fully understand it. Well, maybe not fully, but like the core of it, which is already really helpful, and the rest engineering can always explain. So these can serve as a common ground between product and engineering, and serve as a place where the main flows are defined, and we know that this is what we want to do, not exactly how we want to do it, but it's what we want to do. So this is another technique that I really preach. So now for tech-focused topics, and I may need to start speed things up. Um, so for project setup and tools, this is kind of a given for any product and project that you're working on. Always leverage tools like this one, tools like Husky that make commit message checks, linting and prettiers on the local machine. Don't do this in pipelines. It's a waste of time. It's a waste of resources. PR and issue templates so that everyone on the engineering team can follow the same patterns of how to write templates, of how to write issues. Leverage conventional commits or any other technique that you want, as long as it's a standard regarding commit messages. If you're going to leverage conventional commits, you can also leverage other tools which are really standard right now, like conventional changelogs. This basically means that just by following conventional commit patterns, you're going to have an automatic changelog generated for you for your product. So it's a free tool. Why not use it, right? So I always try to follow these rules, and also add tools like Black Duck so that you can check licensing in the enterprise. This is something that quite often misses. In an enterprise project, you're going to use a ton of open source products and projects, and you're not always going to check the licenses and the details of the licenses. And this is really important because an enterprise can have legal problems regarding this. Tools like this one can make these checks for you, and you just need to add this to a pipeline, and then you're sure that everything is fine. Then for pull request reviews, these are really important. You should make an effort to write good pull requests. Like I mentioned, leverage pull request templates so that the format is always the same. It's always the same format that the engineers are going to expect when reviewing a PR. Invest in making it human readable. You're writing this to an engineer, which may or may not have the whole context or as much context as you have. So try to provide context in the PR, try to provide what you do in the PR, provide images, small snippets of videos to showcase what you're going to do, so that it's easier for everyone to review. Leverage the pool of assignees that can be automatically assigned instead of manually assigning people to review. Leverage tools like ---- amend in commit messages and ---- fix up. These can help in the pull request conversations, and you can explore this after the talk, but these are really useful tools, and I recommend investigating a bit about them and using them. And you can also have integrations like Lighthouse directly in the pipelines for pull requests, like what is the impact that my pull request is going to have on the product performance-wise? Does it slow something? Does it trigger a flag regarding size? Anything that Lighthouse can give you? Or when I mention Lighthouse, I mention any other tool that can have integrations with your product, either front end, back end, whatever helps for you to detect issues earlier on. Then for testing practices, and this is a personal opinion of mine and something that I believe makes a team more performant, but it depends on the cases. So code coverage isn't everything. Just because you have a code coverage of, say, 85% or 19%, that doesn't exactly guarantee code quality. It just guarantees that everything is covered by tests, even if they are stupid tests. And this is really something that is common. Like you create a DTO, which doesn't have anything, like it's a data class, and you're going to test, I don't know, setters for the data class. It's, in my opinion, a waste of time to write these kinds of tests. Don't waste time with them. If they don't add value regarding processes that are for business, then I believe they shouldn't be written. Waste your time writing tests that cover the main flows of your application. Like these should be the ones that you're going to be concerned about. Are my main flows of the business covered with end-to-end tests or integration tests? Do they work? Cool, fine. Do I have a piece of code that is more complex? Then write a unit test for that. But don't write unit tests for everything. Again, code coverage isn't everything, and that doesn't guarantee the code quality as much as big enterprises want to believe that. And as I mentioned earlier, also integration tests with Gherkin and Groovy can help write tests that not only engineers understand, but QA engineers understand. Even product owners can understand those tests because they are adapted to English, basically. Then for API, wait.
Sorry.
Then for API contracts, this is another thing that I saw that helps everyone in an engineering team and in an enterprise product in general. It's really important to have a place or have a way for clients, and when I mean clients, I mean front ends that consume APIs, to understand how can we consume this API. And there are many ways to do this. You have open API specs like Swagger implementations that can provide an interface and a way for clients to know what endpoints there are, what's the payload, what's the answers, what's the status codes of the answers, everything that an API provides. But then the clients have to write everything on their side. They have to have their types on their side. They have to have everything on their side. And when an API changes, a client may or may not be notified. So there can be inconsistencies when API makes changes. Unfortunately, APIs sometimes make breaking changes, and clients won't react to that unless they start getting errors. And that's like an unfortunate way to learn about this. So another way to do this is, again, if you're leveraging, for example, the JavaScript ecosystem, and you're writing a client, a front end in TypeScript, and you're writing a backend in TypeScript, for example, with Nest, you can leverage type packages. So you can have contracts that are in a different package or that are in a private repository in NPM, for example. And the client can actually have the same type that the API is expecting. So this will never collide because the types are exactly the same. This also helps because when the API has a new version, they will update this package. And when the client wants to do something, they will see in the package JSON that there's a new update to the contract. So they need to do some changes or not, but they need to at least analyze what changed in the package so that they can act accordingly and avoid the breaking change, for example, in production for the front end. You also have another technique, which is writing SDKs in whatever language you're going to expect clients to consume your API. This can entail more work, but there are also tools that help write clients in different languages based on open API specs. So you can actually join these two. If you have a good written open API spec, you can leverage tools that read this API spec and they write clients in many languages. And you can provide these clients as packages in the package managers of whatever language you're going to expect clients to consume. And this can be a way also to provide more confidence to clients, because clients will call methods on a class that's written by you and not by them. So it's something that you can also guarantee that communication between clients and APIs will be more secure and will be less prone to production errors. This technique also allows for client mocking on the front end more easily. Again, by sharing types, it's really easy to use tools like MSW to mock data and serve data to a front end as long as the API is not ready, for example. Like I mentioned, it allows for safer communications, and it also allows for contract testing. There are tools like Pact that can actually read your contract package in isolation and make tests against it, like against the expected data, the responses that they provide, and this can also be another step of safety in your production environment.
Sorry, Karin, I was wondering in this slide, yeah, about this. When, in which type of products do you find this most impactful? What?
I think that this helps in any type of product, really, even internal products. If the team is writing the front end and the back end, this still benefits the team. It will avoid miscommunications, but I think it shines especially in public APIs, for example. So if you're writing a public API that you don't know who is going to be the client that consumes it, you don't have control on what they do. And a way to provide more confidence to whoever's consuming your API, since it's public, is by providing the techniques that I mentioned earlier, basically. So that's where I think it shines the most.
Thank you, David. Thank you for your answer.
No worries. Okay, so also ephemeral testing environments are a technique that I saw make quite an impact on a product. These are environments that are spinned temporarily to test, for example, an individual feature. This can help QA test a specific feature more easily since they don't depend on a single environment that's constantly being updated. So maybe QA could do something like going into Slack and writing spin an environment for commit number, hashtag, whatever. And then they have a spinned environment with only that feature merged besides everything that may be in main. It really helps QA, but it also helps product demos. Sometimes you want to speak with product and maybe something in dev is broken because, I don't know, a commit entered that broke something, it happens. But again, if you're going to choose a commit, maybe choose something before the breaking commit entered, and you can still do product demos regarding a feature. It really helps being productive and being agile in the real sense of the term. And lastly, and I'm reaching my time, CI/CD with feature flags is something that I believe everyone should do. Placing in production soon is really important. Getting feedback, real feedback from customers as early as possible is really great. Again, this depends on the products. Some products are really safety focused and maybe they need more time. Maybe they want a release schedule that is different, more planned, more tested. That's fine. But in general, I believe placing in production soon is the way to go. This is great for long-running and complex features. Sometimes features don't happen just in 1 or 2 commits. They happen from 2 teams or 3 teams, 3 different teams, and they need to do stuff in 2 different services and 2 different front ends. And this doesn't happen like from night to day. So this needs coordination, but this doesn't need as much coordination as you would believe, as long as you're using feature flags. If team A does the feature, but it's behind the feature flag, it's not on. So that's cool. Team A puts it into production. Then team B is ready. Then team B then team C is ready. Team D is also ready. Okay, everyone is ready. Every product is ready. Every service. Let's just turn on this feature flag, and everything should work and should be communicating between themselves. So for complex features, this is the way to go too. It also allows for A/B testing. This is more product focus. So it really helps for when product want to make tests. Well, if I change this form to have 2 different fields, would it make a difference in the conversion that we have for the registration? This is a test that can be done with feature flags and percentages of rollouts. This is another thing that is really helpful with feature flags, which they allow progressive rollouts. Maybe I want to give this test or give this feature just to a percentage of the users that use them, that use the product. And when I know that these 20 or 30% of users are using it and they don't have any unexpected problems, they don't have any issues with it, okay, then maybe it's time to roll out to 100% of the user base And this is really something that's really valuable for product especially. And again, at the end of the day, you're always working for a product, so this is really, really important to keep in mind. And these are all the techniques that I want to talk about and mention. Thank you for your time. I hope you liked them. Shoot me a message if you want to speak about anything, and see you soon.
Thank you, David. Amazing. I was wondering, do you want to do a wrap up about everything that you said? You want to highlight the most important things, just to clarify our viewers? Do you want to highlight something? Do you want to wrap up, just to finalize before our Q&A and to launch you a question from? So yes, please, please.
If I had to choose like three things that I think are most important, it would be RFCs, ADRs, decision logs. I really believe they are important. Sequence diagrams are essential, and lately they have been even more essential for me. So I believe that's something that's really, really productive. And lastly, I can't stress more about the importance of API contracts. I really do believe that that makes a lot of difference. So I'd highlight these three.
Thank you, thank you. I think it's important for our viewers to understand what is most important for you, because your talk is amazing, but you touch a lot of points, and I think it's nice to have this kind of wrap up in the end. So before we end, and we're waiting for some questions from our audience. Let's see if they are not shy, and if they ask some questions for you to you, David. After that, before that, all our previous speakers have done it, and they leave a question for the next speaker. And Dominica, leave you this question: have you ever contributed to any open source projects? If so, which one was your favorite and why?
That's a good question. Yes, I have contributed to many open source projects until today. I have contributed to some actually well-known ones like Gatsby, Babel, also Raycast. And regarding I also have many creations of my own that have helped a lot of people over the years. But I think my favorite of them all are the Raycast extensions. So Raycast is like a productivity tool for macOS, something like Spotlight, but kind of on steroids and with a whole community around it. It's still a product, like it still sells, it still make money. You still have to pay for some things, but the extensions, they are open sourced. And I really like the easiness of writing extensions for Raycast, the process of review, and the feeling that a bunch of people are using my extension, and that they are opening issues, they are having troubles with it, but they are reporting it. They have interest in making it work because they are using it daily, and even I use it daily. So I believe that's like the most rewarding thing to me, is writing open sourced extensions for Raycast that I know a lot of people are using every day, and that makes me happy.
Amazing, the working for and with the community. I think it's amazing. Yeah. So we don't have any questions until now. So I will ask you, and before you end it, we end this live stream. What is your question for next speaker? What you want to know about the next speaker? Because we don't have anyone for September, but which what would you like to know about him or her?
I have one that I believe can fit any person, but they will need to think about it quite a lot. So what is the one thing that you would highlight that made you grow as an engineer? What's the one thing that helped the most? If not an engineer, then the profession that you're going to be that you're going to have in the presentation, but most likely it will be an engineer. So I leave that question.
Yeah. Amazing question. Thank you, David. We don't have any questions, but I must say that we had very nice attendance, more than 20 people watching us today. I think it's very good. So thank you for coming. Thank you for your time, and it was a pleasure. See you.
Thank you. See ya.